Okay, here goes the last page of the Chapter 4 review. It's probably good because I don't feel like my voice is going to last much longer. So it looks like we have another rate of work problem. So again, I would suggest that you set up a mold for your problem so that so we can fill the numbers in. So something like 1 over something times something, then space 1 over something times something equals 1. And I'm going to go through and read the problem. So, in a desperate act of corporate espionage, Mrs. Butterworth opened the drain pipe on a 20,000-gallon vat of maple syrup in the Aunt Jemima's syrup factory. The inlet pipe normally fills the vat in 12 hours, and the drain takes 21 hours to empty the vat. How long will it take to fill the vat with both pipes open? So, what I'm seeing here is in a filling pipe and an emptying pipe. So that tells me that these pipes are working against each other. So this is a subtraction problem. And again, I would suggest that you guys have kind of a name for each part of the problem. So here would be my inlet, and then the outlet would be the second part. We want to, it does matter which one you put here and there, because you want to take the inlet minus the outlet, what you're putting in minus what's going out. Just seems more natural. So then it says there's a 20,000-gallon vat of maple syrup. But that has nothing to do with rate. That's just talking about how big the vat is. And so remember, it's just one job to fill the vat, no matter how big it is. So that 20,000 gallons actually doesn't matter at all for this problem. The inlet pipe normally fills the vat in 12 hours. So there's something I need to know. That's the rate for the inlet. And then it takes the drain 21 hours to empty. So there's the rate for the outlet. And then it says, how long will it take the vat to fill with both pipes open? So there's our question, right? How long with both pipes open? So what we don't know is the time needed here. So now that I have that set up, again, if you feel like you can rewrite that as just, t over 12 minus t over 21 equals 1. So I need to get rid of the 12, and I need to get rid of the 21, so I'm going to multiply by 12, and multiply by 21, multiply by 12, multiply by 21, multiply by 12, multiply by 21. So here, of course, the 12s cancel. We're left just with 21 times t, so of course 21t, and then minus, and then here the 21s cancel, so I'm left with the 12 and the t, so that's 12t, equals 12 times 21 would be 210 plus 42, so 252. If I did that math right, let me double check that. I guess I'll just check it. 252. 12 minus 21 is 90 equals 252, and divide by 9, which is 28. So let's go back to the problem. That was 28 hours if both pipes are open. Okay, that one's done. Looks like we have a couple more solving problems to do, and then we'll be done with this review. Let's see. Find and check all solutions for each equation. We got some radical equations here to solve. Remember the first steps there was to get the radical by itself. So I want this piece of the equation to be by itself before I can get rid of that square. So that means I need to add 4 to both sides. So that's going to give me the square root 2 minus x equals x plus 4. Now we can get rid of the square root by squaring both sides. So that's going to give me 2 minus x over here on the left. It's going to be equal to, so x plus 4 times x plus 4. Remember, you don't just drop that exponent in, which is x squared plus 8x plus 16. And since there's a square, I'm going to go ahead and get everything on one side. So I'm going to subtract the 2 and add the x. So 0 equals x squared plus 9x plus 14. So AC method, factors of 14 that had to be 9 would be 2 and 7. So that means x is negative 2 and x is negative 7. So I do need to check those answers for something that's extraneous. So I'll check negative 2 first. Remember, you always plug back into the original equation. So 2 minus negative 2. Square root of that, minus 4 equals negative 2. So 2 minus negative 2 is 4. Square root of 4 is 2. So 2 minus 4 and equals negative 2. Sure does. So negative 2 works. And then checking the negative 7. So square root 2 minus negative 7 minus 4 equals negative 7. So square root of 2 minus negative 7 would be 9. So the square root of 9 is 3. So I get 3 minus 4 equals negative 7, which it does not. So again, how we know this is extraneous, not just wrong. This particular problem, if it had said negative 3 minus 4 equals negative 7, then that would have worked. And so it's just that one sign that's off, which tells me that yes, this is extraneous, not just wrong. So I'm going to label it as extraneous. Okay, so there's problem 8. Problem 9, very similar. I need to get the root by itself first before I can solve this. So minus 11, minus 11. So I have the fourth root of 2x cubed plus 6 equals 4. Then we're going to raise both sides to the fourth power. So that gives me 2x cubed plus 6. So 4 to the fourth power, I believe, is 256. And just go ahead and get x by itself since I only have one x in the problem. So 2x cubed equals 250 divided by 2. So x cubed equals 125. And cube root to get rid of the cube. So that means x is 5. There's only one answer there. Like I don't need a plus or minus because that's a cube root, not a square root. So I just need to check that one answer and make sure it works. So check 5. We can go back to the original equation. 2 times 5 cubed plus 6 plus 11 equals 15. Fourth root, 5 cubed is 125. 2 times 125 is 250 plus 6, or 256. So the fourth root of 256. So you guys, you have the math button on your calculators, where there's the exit root button. So you should be able to take the fourth root of 256 and find out that it's 4. So 4 plus 11 is 15. So there you go. X equals 5 is right. Last problem. So if we got a power this time, we need to get that term that has the power in it by itself before we can solve. Which means I need to get rid of that 10 first. 4 times x to the 3 halves equals 40. And then we get rid of the 4. So that means x to the 3 halves equals 10. And then raise both sides to a power that get rid of that, so I'm going to use it as a reciprocal power. So that means x equals 10 to the 2/3. Now make sure you're not writing 10 and 2/3, right? So don't write it like that. So what that means is that x is equal to the cube root of 10 squared. Well, the cube root of 10 is not a nice number. We use lambda decimal and then squaring it would just get us some other crazy decimal. So I'd actually go ahead and just leave it as the power version. So I was just going to say that x equals 10 to the 2/3 is our answer. As all that checks out, we'll be all good. And we'll go back to that original equation. So check 10 to the 2/3. So 4 times 10 to the 2/3 to the 3 halves plus 10 equals 50. Remember, simplify, don't solve. So these will multiply together and become a 1. So I get 4 times 10 to the first power. And again, you don't need the 1 here. I'm just doing that for emphasis. And then, of course, 4 times 10 is 40. Plus 10 equals 50. Sure does. So 10 to the 2/3 was the right answer. Alright, that is the end of the review. Hope you guys understood everything okay, and that the test goes well for you on Friday. And you have good weekends and safe weekends. And I'll see you guys on Monday when I get back from Texas.